In this module we will review Endpoint Detection and Response, EDR, the features of EDR, and how EDR differs from traditional antivirus software. EDR provides protection by monitoring system behavior in real time, using artificial intelligence or AI to detect suspicious and malicious threats. EDR also provides centralized management of the endpoint security through its cloud-based management console, syncing and saving all reports and information from different devices. EDR does not use signature-based detection to detect malicious attacks. Instead, EDR applies AI and machine learning algorithms to determine if a file is harmful upon execution. EDR includes 8 distinct features. The reputation engine detects and blocks malware once it has been classified based on its reputation. The behavioral AI engines detect malicious activities in real time and monitor every process, service, and file activity on the endpoint. This does not depend on cloud connectivity to detect a threat. Network control controls inbound and outbound network traffic based on rules. Configure device controls to block USB and Bluetooth devices to prevent accidental data leaks or intentional data theft. The EDR agent correlates an attack's chain of events into a single storyline, displaying a graphical view of the detected threat. Network quarantine isolates an endpoint from the rest of the network when a threat is detected. This prevents an attack on other endpoints or communication with an external network from the infected endpoint. It aids in root cause analysis to tighten security controls. Rollback restores the endpoint to its pre-infected version as part of the mitigation action. For example, when the system detects ransomware, the rollback feature will restore all files that were maliciously encrypted or deleted. Application risk management monitors vulnerable applications installed on endpoints and alerts when patches are overdue for updates. Unlike EDR, traditional antivirus relies on virus signatures to detect known malware. Virus signatures tend to change quickly, making it nearly impossible to update a database fast enough to detect new malware versions. EDR also uses behavioral AI to detect both known and novel malware behavior on an endpoint. Traditional antivirus uses heuristic analysis, which detects malware on the endpoint based on its known identified behavior. Lastly, EDR detects fileless attacks unlike traditional antivirus. For instance, traditional antivirus would not be able to detect a threat when clicking on a malicious link since these links do not have an identifiable signature or code. Understanding how both work together to detect malicious activity is essential to realizing EDR's full potential for the greatest level of protection for all endpoints. The EDR agent is deployed to endpoints and includes detection settings built on machine learning and AI processes. New agent releases include updates to threat detection based on novel models developed for an ever-changing threat landscape. Machine learning is based on large, controlled sets of training data that are entered into a machine learning program. The program applies algorithms to the data and determines if the code inside contains threats or is safe. It does this repeatedly to learn how the input behaves in the environment. Once the program learns what is likely to be harmful, the process is validated with a new data set that has known outcomes. Data validation repeats numerous times, as the process is fine-tuned, new parameters set, and higher levels of confidence obtained, resulting in a data model. The final data model is deployed through the agent and used to evaluate real-time traffic on endpoints. This data model is part of the static AI and static AI suspicious engines. These engines work when files are written to disk or accessed. File content is compared to the data model, and threats identified as suspicious or malicious. Malicious threats are immediately quarantined. Behavioral AI is also used in EDR and works to identify potentially harmful behavior by learning what kind of traffic, process, and network activity is normal. Once a network behavior baseline is established, the behavioral AI engines transition from observing to hunting. As they scan operations within each area of focus, these engines identify and mitigate malicious activity as it happens. EDR is different from other types of malware protection products because it learns what is expected behavior in each unique environment. EDR needs to be trained to identify certain activities as malicious or benign. Taking the time to tune the agent and provide feedback is a vital part of configuring EDR within a network.